Internal consistency refers to the extent to which items in a measuring instrument or a scale are all measuring the same thing. It requires only one administration of the instrument. So internal consistency is really about whether different items within a given test that are meant to be measuring the same concept yield similar results. For example, when measuring intelligence, if our theory and definition includes a general component of intelligence, then we typically expect people with a high IQ to get high scores across the different and specific aspects of the intelligence test, which is what is suggested by research on standard commonly used intelligence assessments. For example, the Wechsler subtest is internally consistent. All of its items are measuring the same skill, as evidenced by high correlations among the items. The individual items within the Wechsler subtest do correlate substantially with one another. When it comes to personality, if you think about the five-factor model of Ocean, the theory implies that people will vary across the different dimensions. So in this case, internal consistency is about whether a person answers consistently to the items or questions that measure, say, extroversion, such that each of his or her responses are, say, low on extroversion, and therefore show that he or she is more introverted. One way of measuring internal consistency is to split the test in half, which is, funnily enough, why we call it split half. In split half reliability, we typically randomly divide all items that purport to measure the same construct into two sets. We administer the entire instrument to a sample of people and calculate the total score for each randomly divided half, the split half reliability estimate. For example, let's say we wanted to measure the split half reliability of an intelligence questionnaire that had only, say, 6 items. Highly unlikely, but let's say this is just an example. First, we would calculate the score for the even numbered items. That's 2, 4 and 6. And then calculate the score for the odd numbered items, which is 1, 3 and 5. The split half reliability estimate, as shown in the figure, is simply the correlation between these two total scores. In the example, it's 0.87. Let's say we do this for the end of semester examination. Why wouldn't we just split the first half from the second half? That's a bit of a question for you. Why wouldn't you just take the first half of the exam and split it from the second half? The main reason here is because you might be more fatigued in the second half, so your results to the second half may be a bit lower than the first half. That's typically why we would choose odd items or randomized items and compare the two halves.